Hey everyone, welcome back. This is the 7th question in the differential equations chapter of cracking the GRE math subject test. It's a pretty straightforward question. We're given a differential equation, there it is, and an initial condition, there it is, and we're trying to find f of pi over 2. Now, this differential equation is not separable. That means that no matter what you do, you cannot get all the x's and dx's on one side and all the y's and dy's on the other side. So what we want to do is check if it's an exact equation. What's an exact equation? I'll just give you a little reminder here. An exact equation is a differential equation of the form m, some function m of xy, dx plus n, some function n of xy, dy equals 0. And these two functions m and n, they have to satisfy a certain property, which I'll say in 1 second. And if this is an exact equation, then we're good to go, because then we can solve it pretty easily. Now, if it's not an exact equation, but it's almost exact, and I'll explain what that means, then we can make it exact by multiplying by what's called an integrating factor, and then solve it as we would a regular exact equation. So let's see. We can rewrite this function as dy, or rather, if we multiply all the way through by dx, we get dy plus y over x dx minus, I'm going to bring that sine x over to the left side, minus sine x dx equals 0. Or, if we want to write it the same way that I wrote this general form, m of xy plus n of xy, then we'd have to write y over x minus sine x, all of that times dx plus dy equals 0. Now, the way to check if this function is exact is to see if the partial derivative of m with respect to y is equal, question mark, with the partial derivative of n with respect to x. Well, the partial derivative of m, remember this part here, that's m, and then this part here, it's just 1, is n. So the partial derivative of m with respect to y is going to be 1 over x. That's it. And the partial derivative of n with respect to x is going to be 1. So these are not equal to each other. So this equation is not exact. But we can check if we can make it exact. How do we do that? Well, we have to check if m, the partial derivative of m with respect to y, minus the partial derivative of n with respect to x divided by n is equal to some function of x alone without y. Is it? Well, yeah, it is, because 1 over x minus 1, that's just 1 over x, divided by 1 is just 1 over x, and that is some function of x. And in that case, we can find the integrating factor u of x by taking e to the integral of this 1 over x dx. Well, the integral of 1 over x dx, that's just log x, natural log of x. And e to the natural log of x, that's just x. So that's our integrating factor, x. And the cool thing is that if we multiply the whole equation by this integrating factor, it will become exact. Here, I'll show you. Well, if we multiply through by x, we get y minus x sine x all times dx plus x dy equals 0. Now, this is our new m, and this is our new n, and then the derivative of m with respect to y is going to be 1, and the derivative of n with respect to x is going to be 1. And so we know that this equation is exact. And the way to solve an exact equation is to integrate m with respect to x, which will be the integral of y minus x sine x, all with respect to x. Well, that's going to give us xy minus the integral of x sine x dx. Well, what's the integral of x sine x dx? So we're going to have to do integration by parts. And let's say that this part here is u, and this part here is dv. So that's going to give us xy minus, now remember for integration by parts, the integral of u dv is going to be uv. So x times the integral of dv. So the integral of sine x dx, that's going to be negative cosine x. uv minus the integral of v we said was negative cosine x, du is just going to be dx. The derivative of x is just 1. So let's get rid of all these minuses and we'll see what happens. Well, this part here, the integral of negative cosine, that's just going to be negative sine. So negative makes a positive, and we'll get xy, negative times negative makes positive, so plus x cosine x, and then minus sine x. That's going to be our function, our integral of n. Now the integral of n, that's just going to be the integral of 1, or no, the integral of x, sorry, and we have to take the integral with respect to y. I forgot, here you have to add some function, let's call it little g of y, because when we took the derivative, if you take the derivative of this whole thing with respect to x, then this is going to cancel out. It's going to drop out. So now the integral of x with respect to y, that's going to be xy plus some function, let's call it h of x. So now we see that this xy appears in both of these solutions. And then we've got h of x is going to be our x cosine x minus sine x. That's h of x. And g of y, well, that's just going to be 0. So our solution is xy plus x cosine x minus sine x equals some constant c. That's the form of the solution of an exact equation. Now we're told that f of pi equals 1. Okay, so we can substitute f of pi equals 1. So we know that when x equals pi, y has to equal 1. Well, let's see. Pi times 1 plus pi times cosine of pi minus sine of pi equals c. Well, what's c then? Pi times 1 is pi. Pi times cosine of pi. Cosine of pi is negative 1. Negative 1 times pi is going to be negative pi. And then sine of pi, well, that's just 0. So what do we get? C equals 0. So our equation is actually xy plus x cosine x minus sine x equals 0. And now the question that they're asking us is, what is f of pi over 2? Well, let's plug in pi over 2 for x. We'll get pi over 2 times y plus pi over 2 times cosine of pi over 2. which is 1, cosine of pi over 2 is 0, minus sine of pi over 2, that's 1, equals 0. So this part cancels out, that's 0, and we get pi over 2 times y minus 1 equals 0, so y has to equal 2 over pi. Is that one of the answers? Yeah, that's B.